In our previous video, we talked about all the different parts of our graph, and then we discussed a little bit about the subtleties of our formulas. So now we're just going to do some examples of finding all the information from our equations. So remember, for hyperbolas, we know that it's a hyperbola instead of an ellipse if there's a subtraction sign. And then whichever term is positive determines the direction. So since my x is first in this case, that tells me that it's going to be horizontal. And then our h is always with the x, k is always with the y, and then our a squared is always underneath the positive term, b squared is always underneath the negative term. So I do need to figure out my center, my a, b, and c values in order to figure out the rest of this information. So center is still h and k, and we always do the opposite sign if it's in a grouping symbol. So my center will be -3, 6 for this one. And then vertices are dealing with a, foci is dealing with c. And then when we are figuring out our equation for the asymptotes, we'll need a, b, and the center for those. And I'm getting that from these equations down here. So let's just start by calculating our a, b, and c next. So a is going to be the square root of 25, which is 5. And again, these represent a distance, so we always take the positive number for the square root. And then b is the square root of 9, which is 3. And then to find our c value, we are using this formula right here. So again, it's a little bit different than the ellipse one, because in the ellipse we were subtracting here, but now we are adding. And that's because our c value has to be bigger than the a value, based on where it is in the graph. Okay. So if I'm using c squared equals a squared plus b squared, I'm just substituting in the numbers that I know. So this will be 25 plus 9. So 25 plus 9 is 34. And then I would need to take the square root of that to get c. And that's not going to simplify. So I'm just going to leave it as the square root of 34. So now for the vertices, because it is horizontal from our center, we are going to the left and to the right. So I'm going to add and subtract my a value to the x of the center to get the two different vertices. So -3 minus 5 will give me -8, and then my y will stay the same. And then -3 plus 5 is 2, and then y stays the same again. And for the foci, that is also to the left and right of my center point when it's horizontal. So now I'm going to add and subtract my c value to the x of my center. So the first one will be -3 minus the square root of 34, comma 6, and then -3 plus the square root of 34, comma 6. Okay. And then for the asymptotes, I'm just plugging my numbers into this formula right here, and I know I have to use this one because I'm dealing with that horizontal hyperbola. Okay, so I will have y minus k, which is 6, equals plus or minus, and then this is b over a, so that means I'm taking 3 over 5, and then parenthesis x minus h. And since I am subtracting, this will give me, it'll have to be a plus inside, so it'll be plus 3. Now for the domain and range, again, this is telling me all the x's on the graph and all the y's on the graph. So we are ignoring everything but the U shapes. So I'm thinking of this as opening sideways here and then opening sideways here. Now because our graph is in two parts, that means that we are going to either have two parts in our domain or two parts in our range. So it depends on the direction that it's opening. So I'm going to first focus on just one of the parts. So I'm going to focus on this U shape. So if I was only finding the domain and range of this one, for the x's, it's opening towards -infinity. And then at the vertice here, that would be my biggest x value for this piece of it. So that means that for this problem, it would be at this -8. And then since it's going up forever and down forever as it's opening to the left, the range is going to be all real numbers. Okay. So I'm going to write that down. So we said this was from -infinity to -8. And then my range was -infinity to +infinity, or that all reals. Okay. And then for this side right here, I'm going to go through that same thought process. So this time my U shape is opening towards +infinity for the x's. So the smallest value will be here at the vertex, which is going to be 2. And then as it opens to the right, it's going up forever and down forever. So that means that my range is still going to be -infinity to +infinity. So now I just have to add this piece to my domain. So remember, we have to put in that U shape to connect the two different domains, or the two different parts. And then this is going from 2 to +infinity. So that means that if it was vertical, where our U's were opening up and down, then we would have one part to our domain and two parts to the range. Okay. And if you guys prefer the inequality notation, for the domain in this case, we would say that our x is less than or equal to -8 and, have to be an or. And it's an or because we don't have overlap. So, or we would say x is greater than or equal to 2. Okay. And then in this one, I can write all reals. Or you can use that R symbol, because that means the same thing as all reals. All right, let's do one more practice like that. And then we are also going to do a graph. So as I'm looking at this time my y² term is positive. So that tells me that it's going to be a vertical parabola. So my U's are going to open up and down like this. Okay. So for my direction, this is going to be vertical. And then the center is still h and k. And remember, our h is always with x, k is always with y. So for the center, since I don't have a group symbol here, that means h is 0, and then my k is 1. And then for the vertices, we will have to know A. Foci, we have to know C. And then the asymptotes, we will have to know our B value. And then we need to figure out domain and range. Okay. All right, so again, for our picture, here's my center. And then the vertices are on those U shapes. And then we have the foci inside of our U's. Okay, just to kind of give us an idea of how to find those pieces. So like I said, next we're going to focus on finding our A, B, and C values. So A is always underneath that positive term. So A is going to be the square root of 4, which is 2. And then our B squared is always underneath the negative group. So B is the square root of 9, which is 3. And then we are using this formula to help us find C. So we're going to add A squared and B squared and then take the square root of that. So C squared equals A squared plus B squared. So that means that we are doing 4 plus 9, which is 13. And then since I can't simplify that radical, we are just going to leave it as the square root of 13. Okay. So since my vertices are above and below the center, that means that I'm going to be adding and subtracting my A value to the Y of the center this time. So 1 minus 2 is -1, and then 1 plus 2 is 3. And then the foci are also above and below our center point, so we're going to be adding and subtracting our C value to the Y of our center. So again, the x stays the same, so I'm going to have 1 minus the square root of 13, and then 0, 1 plus the square root of 13. And then for the asymptotes, we are using this formula this time since it is vertical. So y minus k, so this will be y minus 1 equals plus and minus, and then a over b this time, so that will be 2 over 3. And remember, if you can simplify that fraction, then we would need to simplify that. And since our h is 0, when I do x minus 0, that would just simplify to be x. And then for the domain, as I'm thinking about what this looks like, we do have 2 parts, but this time we have 2 parts vertically. So as this U shape opens up, it's going to get wider forever. And as this one opens down, it's also going to get wider forever. So that means this time our domain is the negative infinity to positive infinity. And then our range is going to be in 2 pieces. So we always start with the negative part first. So from this piece, this is going towards negative infinity. And then our highest y value is at this vertice, which is going to be negative 1. So this will be negative infinity to 1, or, so we connect them with that U shape. And then on this U, my lowest y value is here, and then it's going towards positive infinity. So my y value here is 3. Yep, this should be negative 1, sorry guys. And then parenthesis. So that negative 1 is coming from that vertice. Or if you want to write it in the other form, so this one would be all reals. Or as inequalities, we would say that y is less than or equal to negative 1, or y is greater than or equal to 3. And it is important that you are remembering, if you are using the inequality notation, anytime we are dealing with domain, it has to be an x, and then range is always the y. All right, so the last thing we're going to do with this problem is we are going to talk about how to do an accurate graph. So when we do this, we are going to start with the center. So our center is at 0, 1. And then from the center, we are going to go the direction of our a value. So since it's vertical, that means that I'm going up and down a. So I'm going to count 2 up and 2 down. And then I would honestly, to start with, I would label these on your picture so that way you remember what they are. No, you don't have to do that. It's just a suggestion. Okay? And then our co-vertices is dealing with B. So we're going to go left and right from our center point, whatever our B value is. So in this case, 3. And again, if it helps, I would label. And we don't need to worry about graphing the foci. So it's just going to be that transverse axis and the conjugate axis. So once we have these 4 points, we are going to connect them into a box. And I'm going to use dotted lines to do this because remember, this isn't actually a part of our graph. We're just using this to help us graph. So we're connecting these points into a box. And then after we connect them into that box, we are going to draw lines connecting the corners of that rectangle, and we want to make sure that we're going through. So those are going to represent those asymptotes, which help give us the general shape of the 2 U's. So now when I graph the U shapes, it has to go through the vertex point, and then it's going to follow the lines of those asymptotes. But remember, it can't touch or cross over this line. So it's going to look something like this. So the black part is the actual hyperbola. Okay. And we'll do more practice of these in the next videos.